Hi, in this one we're just going to be doing more substitutions, and just I'll do one more basically. I'll just do another example because I didn't get time in the last video, and then we'll just so I'll just start it instead of stuttering. Well, let's have a look at this one. We've got 1 over square root of 10 minus x squared minus 24. Okay, so we got dx. Let's have a look at this. Firstly, do we know how to integrate this? Well, no, that doesn't look like anything that we've done before. Have I copied that down? Sorry, that's supposed to be a 10x. That would make more sense. We don't know how to do this. So let's look at a substitution. Do we know how to do this? Well, we've got an inside function down here. Inside function here. What's the derivative of that? Well, the derivative will be negative 2x plus 10. That doesn't appear on the top line of this integral, so that doesn't help us either. What we can do with quadratics is to complete the square down here. If we complete the square, what we get is another inside function that might just help us to take a derivative, antiderivative. So let's have a look at that. I'll do this. I'm going to probably run out of space again, but I'll just try to be careful. 1 over this. So here we go. We're going to complete the square. So I'm just going to take this negative out the front and have x squared minus 10x plus 24. Okay, so we've just taken that out the front. Right, so we do that. Now we'll complete the square of what's inside of there. So we've got that, negative, and we'll go x minus 5 squared. So that will give us x minus 5 is x minus 10. It'll give us plus 25. I'm just going to take my time because I've got the negative. I'm just going to be really careful. Don't want to screw it up. X minus 10x plus 25. And because we've minus the 25, we need to add 25. And they've got plus 24. So that's all in there. Just make sure I haven't made any mistakes. I've got that minus 24 minus x squared minus 10x. Good. Minus 10x, we need to add 25 there. And that's negative 25, so plus 25. That's all correct. Good. Equals, again, integral 1 over square root. That'll give us negative x minus 5 squared plus 49. Okay, good. That's looking like something that we might be able to integrate, and I'll just show you. I'll just rearrange that a little bit. 1 over, we'll write it in a proper order, 49 minus x minus 5 squared. Now you might say to yourself, that looks worse than what we started with, and I would probably agree with you, but let's just have a quick look at it. What we've got, is there somewhere that you've got an inside function that its derivative is equal to something on the top line? Well, if you look at this here, we've got this inside function here, x minus 5. It's inside of this square, it's inside of this square root, it's horrible, but the derivative of that is equal to 1, which is, we can deal with that on the top line there. Even if it was 3, it'd be, that's fine, because it's still just a multiple of it. So we can do that. So if we say let u be equal to x minus 5, then we have du dx is equal to 1. And let's just see, you might just have to trust me for the moment, let's just see what happens if we substitute that into there. Okay, so this is the square root of 1 over, I wasn't thinking, 1 is du dx over, the bottom line is 49 minus u squared dx. Okay, so let me rewrite that. Those dx's will cancel, and you're left with 1 over square root of 49 minus u squared du. Hopefully you recognize this. Just a reminder that arc sine was 1 over a squared minus x squared. Okay, that was our arc sine x. And so that's what we have here. So this, if we take the antiderivative now, this is arc sine of u over 7, because in this case a is equal to 7 here. Okay, 7 squared minus u squared is equal to that. And so that's our answer, plus c. Fantastic, we're able to do that. And we can't leave it in terms of u. What we need to do is substitute our value of u. What was our u? I've lost it. X minus 5. So this is equal to sine negative 1 of x minus 5 over 7 plus c. And there's your answer. So there's a more complicated one. And the things to look for are, if you've got a quadratic, possibly you could try completing the square if you're looking to make a substitution. That often helps when you have just a constant on the top line sort of thing. You can often, if you can get it into linear, then the derivative of linear is always a number, and that makes integration much simpler. So try completing the square. It might just get into the form that might help you. You might be able to use an arc function, arc sine or arc tan, and get out to an answer. So there you go. Last little piece here. I'm just going to do definite integrals. Definite integrals when substituting. Okay, so we're just going to have a look at that. And so basically the key point is that when you've made a substitution, so when you substitute x for u, so when you bring u in, we don't need to go back. Don't go back to x. Okay, don't go back to x. Leave it in u. Leave it in terms of u. But just change the terminals. Okay. So I'll show you exactly what I mean. So when you've made a substitution and you've got it no longer in terms of x, but you've created a new integral in terms of u, don't go back to x. You don't need to substitute x back in once you've done everything. Leave it in u and just change the terminals. You get the same answer, and it saves a bunch of time. Let me show you an example. So integral of x squared plus 7. Let's take the square root of that times, let's just do x. That's a bit boring, isn't it? Dx. Okay, let's take the integral of that and let's do that from 1 to 0. Okay, finding this. So you look at it and you say to yourself, well, we've got a function inside of a function. What's the derivative of the inside function? Well, it's 2x. And we've got this x sitting there, so we can use that as our derivative, and we should be happy. So you say to yourself, let u be equal to the inside function, x squared plus 7. Therefore, our derivative, du dx, is equal to 2x. There's our little key information for our substitution. Good, and so what is this equal to? This is equal to the integral. What we've got there is the square root of u, not u, and then we've got x here, which is half of du dx. So that's half du dx, okay, dx. Those dx's cancel, and we're left with the integral I'll take half out the front, and we'll go u to the half du. Now what I haven't done is I haven't written down what my terminals are. I just wanted to make it clear down the bottom. Now, because we've changed this totally to u, this is totally in terms of u now, what we need to do is make the substitution. So what we have to look at this is saying this integral is evaluated from where x is equal to 1 and x is equal to 0. So when x is equal to these values, we need to figure out what u is equal to at those values. So when x is equal to 1, u is equal to 1 squared plus 7, which is 8. And so up here we need to write 8 up there. When x is equal to 0, what is u equal to? U equals 0 squared plus 7, which is equal to 7. And so we evaluate u from 8 to 7. So we just put the appropriate u value there according to whatever x value is here. just sub it into this u expression. Alright, now we can do this. Equals half, and then we have this integral. U goes to 3 over 2, and we divide by 3 over 2, and you get 2/3, and we raise that, we evaluate that from 8 to 7. And then we go, I've picked some bad numbers, some bad stuff here, and I'll try my best. But what this is 2/3 8 to the power 3 over 2, minus 2/3 7 to the power 3 over 2. And I'd probably at this stage put that into my calculator. That is just like √3. That's the yeah, nothing very nice. I'll put that into my calculator. So, but anyway, you get the idea. You could keep going to get some. Possibly, I don't think that would clean up very nice. That might be the best answer that you've got. You could maybe take 2/3 out the front. So take 1/3 out the front. So that becomes 3, and I'll disappear. Anyway, but that's the idea. I'll leave it at that. I'll just see how much time I've got left, whether I do something else. I won't do something else. I'll leave it for the next video where I'll just do a slightly more complicated type of substitution. Thank you.